Hi guys, so today we're looking at exercise 4.4, the trapezoidal rule. Our learning intention for today is by the end of this lesson you should be able to calculate the area of irregular shapes using the trapezoidal rule. So let's first look at what the trapezoidal rule is. This is a rule used to estimate the area under the curve. So let's just have a look at our area under the curve here. So we want to find the area under this curve. So what we do is we split it into segments that have equal width, which we call h, and the heights are given by y1, y2, y3. Our final height there we call yn. So to find our area under the shape, we use the formula. The area is equal to h over 2 times y1 plus yn plus 2 times y2, y3 plus y4 plus all the way up to y of n minus 1. This formula is given to you in your formula and table booklets on page 12. Another way to write this formula is to state that your area under your curve is equal to h over 2 times your first height plus your last height plus 2 times the sum of the rest of the heights. Note, if you have an area under the curve shaped like this, your first height y1 is equal to 0 and your last height yn is also equal to 0. So it's important to look out for that in your questions. Okay, let's have a look at an example. So this is exercise 4.4, question 1. So we're given the following diagram and we're asked to find the area, estimate the area under the curve using our trapezoidal rule. Okay, the first thing I'm going to do is go to page 12 in my log tables and write down my formula. So that's my area is equal to h over 2 times my first height plus my last height plus 2 times the height, the sum of the heights in between. So our height h, which is our width, is equal to 12. y1 is equal to 5. yn is equal to 17. And then we have all of the other heights in between that. Substituting these values into our formula and all of the remaining heights, we get our area is equal to 12 over 2 times 5 plus 17 plus 2 times 12 plus 14 plus 11 plus 12 plus 16. So I'm just adding all of those heights in between together. And putting this into our calculator, we get our area of 912 centimeters squared. Okay, so in that question we were told that our unit is in centimeters, therefore my area is in centimeters as well. Let's try another question. In question 4, we're told that the diagram shows the plan of a lake. Use the trapezoidal rule to estimate the area of the lake, given that the offsets are a distance of 10 meters apart and all measurements are in meters. Okay, so the first thing we know is that we're going to use our trapezoidal rule, so we write it down. Our area is equal to h over 2 times the first height plus the last height plus 2 times the heights, the sum of the heights in between. Let's write down what we know. So we know that our width, h, is equal to 10. So all of our segments have a width of 10. And we can see here that y1 is equal to 0 and yn, our first and our last heights, are both equal to 0 in this case. And to find the heights in between, well, we have to add together the height that's above and below our x-axis, or above and below the line shown here. So that would mean that y2 is equal to 15, y3 would be equal to 8 plus 7, which is 15 as well. y4 will be equal to 12 plus 18, which is 30. So let's substitute our values into our formula and find our area. Our area is equal to 10 over 2 times 0 plus 2 times all of your heights in between, which are 15 plus 15 plus 30 plus 42 plus 51 plus 55 plus 22. And putting this into our calculator, we get our area of 2,300 meters squared. Okay, let's have a look at one more example. This is exercise 4.4, question 9. This question is slightly different. We are told that the area of the fields below is estimated using the trapezoidal rule. And it's estimated to be 6.775 hectares. Find the value of x, and your measurements are in meters. We're also told that 1 hectare is equal to 10,000 meters squared. So in this case, they are telling us the area, but they want you to find one of the unknown heights, so one of the unknown y values. Again, it's telling us to use the trapezoidal rule, so the first thing we're going to do is write down our rule. Our area is equal to our width divided by 2 times our first height plus our last height plus 2 times all of the heights in between. Okay, what do we know? In this case, we know that our area is equal to 6.775 hectares. However, all of our measurements are given in meters, which means that we must convert our area value into meters squared as well. We're told in the question that 1 hectare is equal to 10,000 meters squared. So to find our area in meters squared, we multiply our area by 10,000. That will give us 6.775 times 10,000, which is equal to an area of 67,750. So we find our area. We know that our width, h, is equal to 50 meters. We're told that in the question. And we can see from our diagram that y1, our first height is 150, yn is 160, and then we have all of the heights in between. So from here, I'm just going to substitute in what I know, including my unknown value x, and solve for that unknown x. Substituting in my values gives me 67,750 as my area, and that's all equal to my formula. Substituting in the rest of my values, I get 67,750 is equal to 50 over 2 times 150 plus 160 plus 2 times the heights in between. That's 2 times 180 plus x plus 160 plus 165 plus 170 plus 175 plus 175. So from here, I'm just going to simplify out my right-hand side. I'm going to add together my like terms and try and tidy this up a bit. Okay, so adding up to what's outside our brackets. So 50 divided by 2 gives me 25. 150 plus 160 gives us 310. And then adding up what's inside our brackets here, grouping together our like terms, we get 1,025 plus x. So our formula now reads as 67,750 plus 25 times 310 plus 2 times 1,025 plus x. So I'm just adding together my like terms and using BIDMAS to do that, adding up what's inside my brackets first. And from here, I'm just going to multiply out my brackets, okay? So I'm just going to multiply out my brackets, and you guys can probably see I'm actually missing a bracket there, because all of this value, this whole value here, is multiplied by 25. Okay, so this gives me 67,750 is equal to 25 times 310, and multiplying our two to both values inside the brackets gives us 2050 plus 2x. And from here, I'm going to add together my like terms that are inside my brackets. So always brackets first. And we get 67,750 is equal to 25 times 2,360 plus 2x. Okay, so we've added together our terms inside our brackets. We now must multiply. We must expand our bracket. This gives us 25 times 2,360 is equal to 59,000. 25 times 2x is equal to 50x. I now want to solve for x, which means I want x on one side of the equation and all of my numbers on the other side. So I'm going to move my 59,000 to the left-hand side of the equation, so I have x on its own on the right-hand side. So this gives me 67,750 minus 59,000 is equal to 50x, which gives me 8,750 is equal to 50x. I still want x on its own, so at the very end I divide by the value that's attached to my x. So I'm dividing both sides by 50. This gives me x is equal to 8,750 over 50, and dividing that out, we get 175 meters is equal to our value of x. Okay, so when we're looking for an unknown value, we just substitute in what we're given and manipulate our equation so we have our unknown on one side of the equation and everything else on the other side. Please pause and take down this example.